Hello, space and science enthusiasts. Today, we're diving into a question that will keep you on the edge of your seats, eagerly listening. Could an asteroid hit us? Is it possible, like in Hollywood movies, for those massive asteroids to collide with Earth? And if so, how likely is it? Let's delve into this exciting topic and explore what scientists have to say about it. Asteroids typically travel millions of kilometers per hour through space. When an asteroid enters Earth's gravitational field, it experiences a sudden acceleration, determining its entry velocity into the atmosphere. Upon entry into the atmosphere, the asteroid encounters frictional forces. The atmosphere compresses rapidly due to the asteroid's high speed, creating resistance in its path. This friction converts much of the asteroid's kinetic energy into thermal energy. During this process, the asteroid can reach high temperatures from friction with the upper layers of the atmosphere, leading to fragmentation or explosions. Asteroids usually begin to burn up in the atmosphere at altitudes of 100 to 120 kilometers and often break into large pieces due to these high temperatures. Due to gravitational effects, most asteroids continue to disintegrate within the atmosphere and do not reach the Earth's surface. However, in rare cases, larger and more resilient asteroids may encounter more resistance in the lower layers of the atmosphere and reach the Earth's surface. These types of asteroids can often create craters or cause minor local effects. In summary, the primary reason asteroids fall to Earth so fast is atmospheric friction. This friction transforms the asteroid's kinetic energy into thermal energy, causing it to burn up or fragment. This mechanism determines the speed and impact of asteroids hitting Earth. Now let's take a look at some incredible collisions from the past. For instance, the Meteor crater in Arizona, USA. This crater, formed approximately 50,000 years ago, measures over 1,200 meters in diameter and is about 180 meters deep. The impact is estimated to have been caused by a meteorite approximately 50 meters in diameter and weighing 150,000 tons, entering the Earth's atmosphere at a speed of 45,000 kilometers per hour. Can you imagine the impact of such an event? The meteorite, having exploded upon entry into the atmosphere, released energy hundreds of times greater than the atomic bomb dropped on Hiroshima. A collision of such a large asteroid can lead to incredible devastation in the local environment. This devastation could largely destroy plant life and animal habitats, cause landslides, and large fires. However, it is not likely to cause total extinction of all life. Nevertheless, the most significant collisions in Earth's history have resulted in much larger scale destruction. For example, approximately 66 million years ago, an asteroid that struck the Yucatan Peninsula created the Chicxulub crater and led to the mass extinction of dinosaurs. This impact caused global climate changes and significant ecological devastation. So, how often do such collisions occur? Fortunately, large-scale asteroid collisions are rare events. The likelihood of a 1-kilometer asteroid colliding with Earth occurs approximately every 500,000 years. Smaller-scale collisions, however, happen more frequently. For example, millions of small asteroids burn up in Earth's atmosphere each year before reaching the surface. Most are harmless and go unnoticed. The impact of an asteroid on Earth can vary in size and consequence. Primarily, a collision of a large asteroid can result in a local catastrophe. For instance, a 10-kilometer asteroid colliding with Earth could cause a mass extinction event similar to the KT extinction that led to the extinction of dinosaurs. A collision with a 1-kilometer asteroid could cause significant regional and local effects. An asteroid of this size could lead to massive fires, tsunamis, earthquakes, and short-term climate changes affecting a wide area. If it were to explode in the atmosphere, it could also create significant energy release and shock waves. Smaller asteroids usually burn up in the atmosphere or break into smaller pieces before reaching the Earth's surface. However, depending on their size, they can create small craters on the ground or generate powerful shock waves through atmospheric explosions. The impact of asteroids can have regional effects as well as global consequences. Especially large-scale collisions can have long-term effects on biological diversity, disrupting ecosystems severely. They can also significantly affect agriculture, human settlements and lead to long-term climate changes. Therefore, understanding the potential impacts of asteroid impacts and taking measures against such events can be achieved through continuous scientific research and monitoring by observation networks. Tracking asteroids in space and predicting potential collisions are crucial steps in protecting Earth. International cooperation and scientific efforts are essential in this regard. The largest recorded asteroid impact on Earth occurred in 1908 in the Tunguska region of Siberia. This event resulted from the entry of a massive meteorite or fragment of a comet into our atmosphere, causing a tremendous explosion. The Tunguska event occurred on June 30, 1908, near the Podkamennaya Tunguska River in Siberia. The explosion occurred at an altitude of approximately 50-60 kilometers in the atmosphere. As a result of the entry of the asteroid or comet fragment into the atmosphere, it exploded with an estimated power equivalent to 10-15 megatons of TNT. This was much more powerful than the atomic bomb dropped on Hiroshima. The explosion devastated an area of 2,000 square kilometers, uprooting trees from their roots, causing them to fall and starting a large fire. The local wildlife also suffered significant damage. Fortunately, the region's remoteness and the explosion occurring far from civilian settlements minimized human casualties. Following the Tunguska event, the potential for asteroids or comet fragments to strike Earth began to be taken more seriously. Today, various observation and monitoring systems have been developed to prevent similar events from recurring. Now let's return to the present day. Is there a massive asteroid threatening us in the sky right now? According to scientific research, the likelihood of a large asteroid colliding with Earth within the next 100 years is very low. This is certainly reassuring news for all of us. However, this does not mean there is no danger in the sky at all. In fact, small-scale asteroid collisions occur regularly every year. According to NASA, an asteroid the size of a car enters Earth's atmosphere and disintegrates here every year. These asteroids usually burn up due to high-speed friction upon entering the atmosphere and largely fragment. During this process, when they reach the Earth's surface, they are mostly in much smaller pieces and generally do not cause significant damage. However, occasionally, larger asteroids, depending on their size, can reach the Earth's surface without completely burning up in the atmosphere and potentially cause damage locally. When it comes to larger and potentially more dangerous asteroids, scientists are constantly scanning the sky and monitoring potential threats. These monitoring efforts are conducted through various telescopes and radar systems worldwide. Additionally, there are special programs, such as near-Earth object programs, that monitor asteroids and comet fragments passing close to Earth. These programs aim to detect large asteroids as early as possible and take necessary measures in case of a collision. National space agencies are developing various strategies and conducting significant research in response to asteroid threats. NASA uses extensive observation networks under the Potentially Hazardous Object Program to monitor asteroids and assess potential collision risks. Similarly, ESA's Space Situational Awareness Program conducts similar monitoring and tracking activities. These agency efforts have achieved significant successes. For example, NASA's NEOWISE mission has made significant advancements in recent asteroid monitoring and characterization. Since 2010, NEOWISE has discovered thousands of asteroids and determined their characteristics. These data have improved our understanding of potential collision risks and enabled us to take necessary precautions. ESA's SSA program has significantly enhanced Europe's ability to monitor objects in the sky. ESA's space-based observation systems track hundreds of asteroids daily and share this data with other space agencies through international cooperation. These efforts are becoming more effective through international collaboration strengthened by global space agencies. In this way, a defense network capable of protecting the world population in the event of a potential asteroid collision is being established. In conclusion, while the likelihood of a large asteroid colliding with Earth in the next 100 years is very low, it is comforting to say that there is no need to panic. Scientists conduct continuous research on asteroids and other space objects, aiming to detect potential threats in advance and take necessary precautions. These efforts are crucial for the security of Earth and are advancing every day. Space agencies monitor asteroids through telescopes and satellites, developing various strategies to minimize collision risks. As space enthusiasts, we can continue to follow these exciting and important efforts closely. Every new discovery about space reminds us of the vastness and mysteries of the universe. If you enjoyed this video, please subscribe to our channel. Also, don't forget to turn on notifications to stay informed about our new videos. You can find many more interesting and informative contents about space and science on our channel. It's a great pleasure for us to continue this journey of exploration with you, our valued viewers. Until next time in the next video, take care and goodbye.